How's everybody doing today? Welcome to the experiment number 11, alcohols and phenols. In organic molecules, specific groups in the molecule determine the physical and chemical properties of the molecules. And those groups are called functional groups. You have already studied alkanes, alkenes, alkynes, and aromatic compounds. When the compound has the functional group OH minus, the hydroxyl group, it is called an alcohol. And alcohols can be primary, secondary, or tertiary, depending on the number of carbon groups attached to the carbon-bearing OH group. Let's say it again. Depending on the number of carbon groups attached to the carbon-bearing OH group. For example, let's look at methanol. Is this primary, secondary, or tertiary? Let's draw this in a different way. We have only one carbon. Carbon has valence 4. Bond to the OH group, the hydroxide group, and the rest is hydrogen. In this case, methanol is not even bonded to one more. This carbon, let's do it in another color, is not bonded to any other carbon. We can say primary alcohol. Let's look at ethanol. Let's draw it in a different color. This is ethanol. Ethanol has 2 carbons. So let's draw it in a different way. 2 carbons. 1 carbon is bonded to 3 hydrogens. And the other carbon bearing the OH group has 2 hydrogens and 1 OH. Now, let's look at our definitions depending on the number of carbon groups attached to the carbon bearing the OH group. In this case, this is the carbon bearing the OH group. If that carbon is bonded to just one other carbon, we say this alcohol is a primary alcohol. This carbon bearing the OH group is bonded just to one other carbon. The others are 2 hydrogens and 1 OH. Now, let's pay attention at 2-propanol. And let's draw 2-propanol right here. We have propanol. You know it has 3 carbons, but we said 2-propanol. So the OH is in carbon 2. And here, CH3 and CH3. Now let's go to our definition. This is the carbon bearing or bond to the OH group. And we said depending on the number of carbon groups attached to the carbon bearing the OH group. This carbon in red is bonded to 2 carbons, right? One here and one here. Then it's a secondary alcohol. And when the carbon is bonded to 3 other carbons, for example, the third butyl alcohol, we say that it's a tertiary alcohol. And this is the OH. So when we look at the carbon bond to the OH, we see that it's bound to 3 other carbons. Then it's a tertiary alcohol. So that is how we classified the alcohols. Now, when the carbon, let's look at this. When the carbon bonded to the hydroxyl group is directly bonded to a carbon that is part of an aromatic ring, the alcohol is called phenol. Like here, this carbon that is bound to the hydroxyl group is part of an aromatic ring. Then we call it a phenol. So this is a phenol. And look at this. Is this a phenol? Yes. Why? Because the carbon that is bonded to the hydroxyl group is part of an aromatic ring. And phenols and alcohols both have the hydroxyl group, but phenols are more acidic than alcohols. Remember that you will test the acidity of different alcohols and phenols. And another characteristic of alcohols and phenols is that they are polar compounds. Why is that? Let's pay attention at this drawing. They are polar because the hydroxyl group in the alcohol is polar and can form hydrogen bonds. Let's pay attention to this drawing. These are molecules of water. The circle in red is the oxygen. So water has 1 oxygen and 2 hydrogens. So they draw the water like that. In red is the oxygen. This little circle in white is the hydrogen. And in this picture, we have 3 molecules of water, 1, 2, and 3, and we have the methanol or the methyl alcohol that is this one. So methyl alcohol is just 1 carbon, 3 hydrogens, and 1 hydroxyl group. So if you pay attention, the carbon is the circle in black. The little circles in white are the hydrogens. And here, the OH is this circle in red is the oxygen from the hydroxyl group in the methyl molecule. And it's bound to a hydrogen that is that little circle. So why are these compounds polar? Polar because the oxygen is electronegative and there is partial negative charge on the oxygen. Is basically the oxygen attracting the electrons towards the oxygen and leaving a positive density charge on the hydrogen. And why are they soluble in water? They can form hydrogen bonds with the water. So these lines that are here, 1, 2, and 3, are the hydrogen bonds that makes the alcohols soluble in water. What are hydrogen bonds? You already studied. Like the negative charge of the oxygen forms a bond with the positive charge of the hydrogen from the water. And the positive charge of the hydrogen here, look at this. The hydrogen from the hydroxyl group from the methyl forms a hydrogen bond with the oxygen from the water. This is another characteristic, another physical property of the alcohols. And the objectives of today's experiment is to learn different reactions for alcohols and phenols and use them to identify an unknown compound. So let's look at our report and what do you have to do. This is how it's going to look, your report. This is a blank report, but let's go over it. The first thing that you are going to be asked is to draw the structures for the following compound. You can actually do it in a paper and then upload a picture of that part in your computer. So you have to draw the structures of 4 different alcohols: ethanol, 2-propanol, 2-methyl 2-propanol, and phenol. So let's look at this. How are we going to draw? The first one, ethanol. First of all, if you notice, all the ending in the alcohol is OL. Now, ethanol, you already know that ethanol, ethyl group, has 2 carbons. So ethanol, the structure, will be just 2 carbon, CH3, CH2, OH. That is the structure of the ethanol. Let's look at 2-propanol. 2-propanol. Prop, you learned propyl, has 3 carbon. So we are going to write the carbon chain with 3. And then it says 2-propanol, which means that the OH is in carbon 2. Very good. And then we just need to complete with hydrogens, because carbon has to have 4 bonds, and the rest will be the hydrogens. So this is going to be the structure of 2-propanol. Now, they asking for, let's erase this. They are asking for the 2-methyl 2-propanol. Okay, this pencil is not working. 2-methyl 2-propanol. So because it says prop, the main I start drawing like that. Has 3. But then it says 2-methyl. That means in carbon 2, I have a methyl. And it says 2-propanol. So in the carbon 2, I also have the hydroxyl group. And then I complete with hydrogen. So this is how I draw 2-methyl 2-propanol. And in parentheses, it says terbutyl alcohol. This is a tertiary carbon, a tertiary alcohol. Why is that? Because the carbon bearing the OH group is bound to 3 other carbons. Then we have a tertiary alcohol. And then they are asking, this belongs to this one, to draw the structure of a phenol. What did we mention about the phenol? We mentioned that the carbon bearing the OH group is part of an aromatic ring. You can draw it this way, or as you saw, you can do this, and this is an aromatic ring. Either one. But if this carbon bearing the OH group is part of an aromatic ring, then you are in the presence of a phenol. Very good. So this is the first thing you will have to draw. Here in this drawing, you will see that instead of writing the structure, you can also write the bond line structure. So for example, for ethanol, you can either write this, or you can do this that you have studied in lecture, the bond line structure. Very good. The next thing that you are asked to do in the report is to classify each structure as primary, secondary, or tertiary. So we saw that. We saw that ethanol, for example, the carbon bearing the OH group is bound just to one carbon. So then ethanol is going to be primary. And then you do the same for the other two. Next things you are asked to do in the report is doing 2 experiments to test the physical properties of alcohols and phenols. The physical properties. What does that mean? You are going to test the solubility and the pH of different alcohols. Let's start first with the pH. All this data that you see here is taken, since you are not doing the lab in face-to-face, you are given, let me share the page, you are given the data. So let's look at this. You will have to get the sample data and copy into the report. And this is different. Let's start with the pH. So basically, you are giving this information. How are you going to test pH? You will add 10 drops of these 6 different alcohols: ethanol, 2-propanol, 2-methyl-2-propanol, cyclohexanol, phenol, and your unknown. You will have to guess, or you will have to identify, comparing to the results of the other known alcohols. So you will add 10 drops of these 6 different alcohols and then test the pH with pH paper. You basically place a drop on a piece of pH paper, and depending on the color that you obtain, you will have the different color, and you will have a scale, and you will write the pH of each alcohols. Let's pay attention just at one thing. Let's read the data. The ethanol pH is between 5 and 6. 2-propanol, similar. 2-methyl-2-propanol, similar. Cyclohexanol, 5. And look at phenol. Phenol, 1, 2. There is a big difference. So just keep that in mind, that phenol, even though it's an alcohol, is much more acidic than the other alcohols. So if you are trying to find out if you have a phenol or an alcohol, you can do the pH, test the pH. If the pH is between 1 and 2, you know you don't have an alcohol. So the acidity is one way of differentiate between phenols and alcohols. Then you will test the solubility. So you will be given that the solubility of these 6 alcohols in water. You will add 40 drops of DI water in each of these 6 alcohols. And you will test the solubility. Soluble compounds will show a clear solution. If you add water and you see a clear solution and no separate layers, then you are in the presence of a soluble compound. But insoluble compounds will show a cloudy mixture or 2 separate layers when you add the water. So this is the first test that you are going to perform. The next test is the chromic acid test. Let's go back. So you are given this data. You will add just 8 drops of each of the 6 alcohols, same alcohols: ethanol, propanol, 2-methyl-2-propanol, cyclohexanol, and phenol, and your unknown. And you will add 2 drops of chromate solution. If the alcohol oxidizes, the color will be green. That is what you need to know. Green means a positive reaction, means that the alcohol oxidizes. If the color stays brown-orange, the reaction is negative, no oxidation. And this is a test to distinguish primary and secondary alcohols from tertiary alcohols. And phenols are oxidized to a brown color. So let's go back and look at the write-up of this experiment. Let's look at the information given for the chromic test. If we have a primary alcohol, it will oxidize and the color will change from orange to green. And you need to know what happens. If the alcohol oxidizes, what does that mean? That the alcohol oxidizes means that it forms an aldehyde group. You will have to learn the functional group aldehyde. And the chromate reduces to chromium ion plus 3, that is a green color. So let's understand why tertiary alcohols produce a no reaction, a negative test. In order for an alcohol to be able to be oxidized, the carbon bearing the hydroxyl group needs to have at least one hydrogen. In this case, in the primary alcohol, this carbon is bonded to 2 hydrogens. Then it can easily oxidize to an aldehyde group. This is an aldehyde group. Instead of a hydroxyl group bound to the carbon, you have a carbonyl group. And the carbon is bound to just one other carbon and one hydrogen. So the aldehyde group is a carbon bearing a double bond and a hydrogen. So we said that in order for an alcohol to be able to be oxidized, you need a hydrogen bonded to the carbon that has the hydroxyl group. So primary alcohols have, secondary alcohols have, look at this hydrogen. This is the carbon bearing the OH group, is bonded then to 2 other carbons, 1 hydrogen and 1 hydroxyl group. So then secondary alcohols give a positive chromic test. You will see the green. But the tertiary alcohols, the carbon bearing the OH group, is bound to 3 carbons, no hydrogens there. So we obtain a negative reaction. So now that we know that the chromic test oxidation is to distinguish primary and secondary alcohols from tertiary alcohols, we will move on to the next reaction. The next reaction is the iron chloride test. We add 5 drops of each of these 6 alcohols, and then 5 drops of iron 3 chloride to each tube. And this reaction is to identify phenols, just phenols. Phenols react with iron 3 chloride, forming a colored compound solution. And the color depends on the structure of the phenol. It could vary from green to purple. But here, they're not giving that much information. But they are saying that it forms a color solution. Let's go back to our report page. So the first thing, we saw this. We classify this. This is data that I obtained from the data sample. And it's interesting, as we said, the phenols are more acids. And here we have to complete, before actually we go to the iron chloride test, we have to complete this part of the report. So the color, what did we say? If we see a green, it's positive. So the ethanol produces a positive reaction because we see the green. 2-propanol gives a positive reaction. How about the tertiary alcohol? No, it's a negative reaction. It's no reaction. No reaction. Very good. How about cyclohexanol? It's a secondary alcohol. So then we will obtain a positive reaction. How about phenol? Phenols can also be oxidized. Instead of green, we will see a brown, but they are giving a positive reaction. And we are obtaining a product that is benzoquinone. But they are asking here to write the condensed structure formulas of the original alcohols and the product. So let me share the whiteboard to show you what is a condensed structure formula. Very good. When we have a structure formula, we use lines to show the bonds between the atoms. But they are asking us to write a condensed formula. And the condensed formula omits most of their bonds. For example, when we have, just to give you an example, this compound, this is an aldehyde. These are all hydrogen. So this is a structural formula. But if I tell you write the condensed formula, what you do is you don't write the bonds and you try to condense. So this part, you will write CH3. Then this part, you will write CH2. And then this part, the aldehyde part, you write CHO. When you write CHO, please do not write it on the other way, COH, because this is a clue of an aldehyde, which is this group. So this would be the condensed formula. Let's do another example. For example, if we have this compound, and I ask you, please write the condensed formula. You will write this part, CH3, then the next part, you will write CO, CO, and then the last part, we write CH3. Very good. Now we are ready to go back to our table. So the first alcohol that we need to write the condensed formula is ethanol. Ethanol. And we perfectly know that ethanol is 2 carbons This is the structure of ethanol, but they're asking me to write the condensed structure formula. And they are saying of the original alcohol and product. Very good. So from the original alcohol, it will be easy. CH3, CH2, OH. This is the condensed formula of the alcohol. But what happens when the alcohol oxidizes? Oxidizes with chromic acid. What is the product? This part stays the same. And the carbon bearing the OH is going to form a double bond with oxygen. And the product is going to lose a hydrogen, and we obtain an aldehyde. This is the product of the oxidation. Ethanol. Let's write it here. Ethanol. And they are asking in the report to write the condensed formula for the original alcohol, which is our ethanol, and the product. This is our product. So how do we write the condensed formula? We write CH3, CHO. Remember I just said that this is the condensed way that we write the aldehyde group. Very good. And then they are asking to do the same with 2-propanol. So 2-propanol, let's write in this way. First, I would recommend you to start writing first the structure formula. And then it's a skill to convert it into a condensed formula. In this case, because the carbon bearing the OH has 2 methyl, the condensed formula would be CH3, 2, and then CHOH. notice that this OH is this OH, and this hydrogen is this hydrogen. Very good. And then what is the product when this oxidizes? Well, when this oxidizes, we said that the carbon bearing the OH converts into a ketone, and one hydrogen is lost. If we have to write the condensed formula, we are going to say 2CH3 and then CO. And this carbon is this carbon. And this oxygen is this oxygen. Very good. And that's how you are going to continue with all the other alcohols. Before we move, let me show you the phenol. What is the code for the phenol? Let's erase this. This is the phenol group, right? Very good. We can write this structure in a different way, just for you to understand a little bit better the structure of the aromatic. Each carbon is bound to just one hydrogen in the aromatic ring. So the condensed rule for the phenol, which would be, let's say, for all this group, you just write carbon 6, hydrogen 5. Every time you see carbon 6, hydrogen 5, you are talking about an aromatic ring. And then you just add the OH. So this OH is this OH. Very good. And what happens when the phenol oxidizes? It will give you a brown color. Because when this oxidizes, actually, it gives you a structure. Let me write it here. It gives you this product, which is benzoquinone. Very good. So they will ask you for the condensed formula. You can even write, I would add this, and I would write benzoquinone, but you can also say carbon 6, hydrogen 4, oxygen 2. This is the product of oxidation, one of the products actually of oxidation of the phenol. Very good. Let's go back to our page of the. So now we know how to complete the condensed formula and the classification. Classification, we know that ethanol is a primary alcohol and the product is an aldehyde product. For the 2-propanol, we know that is a secondary alcohol and the product is a ketone. And we said that for the phenyl, it's a benzoquinone. Very good. The next test that you are going to perform is the iron chloride test. What did we say? We said that this reaction is just to identify phenols. And you are going to, the colors, you are going to test the same alcohols, the same 6, and you are going to find the color from the sample data. And then the only one that is going to give you a purple is the phenol. And that's how you know it's just to identify phenols. It could be depending on the phenol. The color can vary from green to purple. Usually the color is purple. And then the last part of the report is to identify your unknown. So depending on the data, on the sample data, you will compare and you will find out which one actually you need to use the result of the test, as we just said. But the easy part is that it's going to be one of the 5 compounds used in this experiment. So you know that is either ethanol or 2-propanol or 2-methyl 2-propanol or cyclohexanol and phenol. So you will compare your unknown with those 5 and decide which one is your unknown. Very good. This is basically all, and then you will have to draw the condensed structure formula of your unknown that we already went over that. And before we go, I want to make sure to ask a few questions on make sure the main points are understood. For example, how do you know if you have a phenol or a alcohol? How do you distinguish that? Well, we said that we have this test, the iron 3 chloride test, and what else? What else is different with phenols? Remember the acidity test. They are much more acidic than the other alcohols. Then, before we conclude this workshop, I want to show you, I want to share the page. Sorry about that. So the last question, before we conclude the workshop. If I have this molecule and I have this molecule, we said that alcohols are polar. Which one is more polar? Think about it. Both molecules have the polar group OH. Both are polar. But look at the non-polar portion. This is the non-polar portion of the alcohol. Which one is shorter? The one that is shorter is obviously going to be more polar. And how about if I have an ether? Which compound is more polar? Remember that the ethers do not have the hydrogen as the alcohols do to form an additional hydrogen bond. So which one is going to be more polar or more soluble? Very good. You got it. And that will complete our workshop for today. And I would like to thank everybody for listening to me. And I'm looking forward to seeing you next week for our last experiment, that is peptides and proteins. Thank you all.